So we've done the theory for Taylor's polynomials, and now we've got to put that into action. So we've got to find the first 5 polynomials for this function y equals sine x at x equals 0. So what have we got? We know that the general rule for Taylor's polynomials is summation from k equals 0 up to some n value of the derivative a over k factorial x minus a to the power of k. So that's the general rule for Taylor's polynomials. We've got to have a look here and say, right, oh, well, we can go k equals 0 to k equals 1 to get the first, etc., etc., etc. What else does this question tell us? What is f of x? So this also tells us that f of x is equal to sine x. And this little bit of information down here tells me that at x equals 8 tells me that a is equal to 0. So this can be changed now to Pn x equals the sum k equals 0 to n of f k of a, which is just a is equal to 0 over k factorial, and then instead of that a there we'll just have 0, so that'll be x minus 0, which is just x to the power of k. So in this particular instance, because we're working from x equals 0 around that point, this will be my Taylor series or Taylor's polynomial, which is Maclaurin's series. So it will help us probably to just write down what f of x is and f dash of x, and then substitute these values in. So we want to get all the way up to the 5th order, so we can say that f of x, so we're going to have to do some substitutions for f of x and f of 0. So f of x is nothing more than sine x. So f of 0, which is also we're going to need, is sine of 0. And from your unit circle you know that that's equal to 0. We will then need f dash of x, and the derivative of sine x is cos x, and f dash of 0 will be cos of 0, and cos of 0 is equal to 1. We want all the way up to the 5th, because this is when we do the 5th order, we've got to have the 5th derivative. So f double dash of x, which is the second derivative, which is the derivative of the first derivative, is negative sine x, and f double dash of 0 will be equal to minus sine of 0. Sine of 0 is 0, so that's equal to 0. F triple dash x is equal to the derivative of minus sine would be negative cos of x, and the third derivative when we put 0 would be minus cos of 0, and the cos of 0 is 1 minus cos of 0 is equal to negative 1. The fourth, we use Roman numerals of x, derivative of minus cos, we get back to sine. So the fourth derivative when we put 0 in for x will be sine of 0, which is equal to 0. And lastly, the 5th of x will be equal to derivative of sine, so we're back up into this pattern here, cos of x, so the 5th derivative with x equals 0 will be equal to cos of 0, which will be equal to 1. Okay, now we've done all those because we've got to find all the polynomials, the first, second, third, and fourth and fifth polynomials, so we're going to use all of those bit by bit. Okay, so let's put it together now. So we want the first polynomial, so P1 of x So we want all of the sum of these from k equals 0 to k equals 1. So that will be when k is equal to 0, we simply just get f of 0, and then we'll have k is 0, 0 factorial is 1, x the power of 0 is 1. So that'll be just f power of 0 plus, now we put k equals 1, so that'll be f dash 0 over 1 factorial, which is 1, x the power of 1, which is equal to 1. X power of 1, which is just equal to x. Now, what is that? F of 0, we've already worked out up here, is 0 plus f dash 0, which will be 1 times x. So that'll be just equal to x. So there's the first order polynomial, Taylor's polynomial, for y equals sine x. P2 of x will be the first order, so it'll be these. Zero in there, plus the second, so the second derivative, 0, all over 2 factorial x squared. So these two terms we've already calculated above, and they are just equal to x, so all we've got to do is just add this one here. Now the second derivative with x equals 0, we pick up from here, and we get 0, and then, so this is 0, it doesn't matter what this is equal to, the whole thing's going to be equal to 0, so that's also equal to x. So the second order Taylor's polynomial is the same as the first order. P3 of x will be, it'll be the second order, which will be just equal to that, plus the next term. Now the next term will be f triple dash 0 over 3 factorial x to the power of 3. So all it is just adding on all of this plus the next term in the series. So rather than write all that, that's the same as P2. So it'll be just that plus that. Now we know that P2 is just equal to x plus the third derivative I'll pick up from there, so that's negative 1 over 3 factorial. 3 factorial is 3 times 2 times 1, which is equal to 6. And that'll be x cubed. So that'll be x minus x cubed on 6. So there's the third order. The fourth order is equal to P3. So it'll be the third order plus the next term. And that'll be f, the fourth derivative with 0 in there, over 4 factorial x to the power of 4. And we get that there, so that will be all equal to 0, that term, so it'll be just the same as the third order, and that'll be x minus x cubed on 6. And lastly, we pick up the fifth, was the last one we need, and that's P4 plus the next term will be the fifth derivative with 0 in there, all over 5 factorial times x to the power of 5, and with that we get, it'll certainly be this one first, so x minus x cubed on 6. Now the fifth order with 0, so the fifth derivative with x equals 0 gives me 1. 5 factorial is equal to 5 times 4 times 3 factorial, so that's 120. So that will be 1 over 120 times x to the power of 5, which is equal to x minus x cubed on 6 plus x to the power of 5 over 120. So there's the first 5 Taylor series, so order 1, order 2, all the way up to order 5. You can see that they all aren't different, that the first 2 order polynomials are just x, the next 2 remain the same, and then the fifth one And you could probably guess that the sixth one will probably be the same as that one there if the pattern stays the same. How close is this and how good is this as an approximation for sine x? So now this was about x equals 0, so at x equals 1, now don't forget x is in radians, so that's x equals 1 radian. Not exactly too close to x equals 0, and it's a bit of a way away, but at x equals 1, sine of 1, so don't forget that's 1 radian, so you must have 1 on the radians in your calculator. Sine of 1, the actual true value, is equal to 0.841667. So that's the true value. By Taylor series, P5 of 1, so this is the fifth order, will be equal to 1 minus 1 on 6, putting 1 in here for x plus 1 over 120, and you get that is equal to 0.84167. So in other words, it's a very good approximation by putting this in, even going to the fifth order polynomial is a good approximation. If you would have used, say, P1, so by Taylor series, and we go back up, what was the first order? The first order was just equal to x, so P1 of x is just equal to x, so it will be equal to 1. And that's not good enough. It's not a close approximation to what the actual value is. Obviously, P3, 3 and 4 were the same, will be closer to this value than the 1 is. So you can see that the more terms you take, the closer the approximation becomes. Okay, so that's how to work out Taylor's series or Taylor's polynomial for any given function. We'll do another example in the next one as well.